Good morning, everybody. How are you all doing today? Chilly this morning, huh? Well, it's supposed to be up to 70 today, so it's still a fairly nice fall day. Well, we're not quite. Actually, we're technically in fall, aren't we, now at this point? In fact, today, is that correct? Today is the first day of autumn? Yes, today is, in fact, the first day of autumn. What? It is actually the first day of autumn, meteorological autumn. Astronomical autumn, whatever you want to call it. I don't know which is which anymore. Right, right. First day of fall. Anybody do anything fun in fall? What is your favorite fall thing? What is your favorite? Hey, Donovan, you're marked away. Can you mark yourself as present? Just take the little face with the clock, hit it again under your name. Cool, thank you. Pumpkin patches, Halloween, football. Anybody love fall football? Is that a big deal? You guys watched the Packer game yesterday? Brewers are really close to clinching a wild card spot for the postseason baseball here. I mean, that's pretty much in the bag. So we'll be watching a little postseason baseball, maybe. We'll see if hopefully they can get that wild card spot for sure. Get in. So that's a favorite thing, Donovan? That cold winter's coming? You like winter? Some people do. People are really into like snowmobiling and um, you know, ice fishing and all that fun winter stuff too. Not me. Not a big fan. I would be a snowbird if I could. I'd relocate in the wintertime, go live in the south, come back. I'd probably stay through Christmas, enjoy the early part of winter and then be done until spring. But obviously that's not something that everybody can do, especially when you're not retired and stuff like that. So maybe when retirement comes. I doubt it. I do know that potentially, I don't know, every year, we say this and then we really hate winter for a couple of months and then it's over. So at that point, is it really worth it? I don't know. Oh, so winter is was that supposed to be a Game of Thrones pun there, Donovan? You said cold winter is coming, but winter is coming. Ah, just really flew over my head. And I'm a huge GOT fan. So for me, fall, I'm going to be decorating hopefully soon for some, a little bit of fall decorations, some Halloween decorations. Those are fun to put up. I just haven't really had a lot of time. We went out kind of western Wisconsin to the Necedah area, Mauston area this past weekend. Anybody from that area? We're in your neck of the woods. To Buckthorn State Park. Did some hiking. It was fun. Yeah, it's a nice little area over there. They got some nice geography, some cool features. So that's where we ended up this weekend. We like to travel just around the state. The goal is to be able to get to every state park in the state of Wisconsin. Don't have a timeline there, but just we hit up 3 this past weekend, so that was fun. And maybe just a few more coming up here. But anybody a big hunter? We got the duck hunting season opens this weekend. Anybody duck hunters in here? Nope, no duck hunters. Where's your neck of the woods, Cody? And you have to realize that my geography is terrible. An hour north of Green Bay, like in the Oconto area. Crivets? Yeah, Crivets. Yeah, we've been through there before. I'm sure the last time we went up north, we stayed closer to Anago. I think it was in the Eagle River area. It's have terrible geography. So, all right. Well, I suppose we should probably get started. We have a lot of things to cover today. We're going to be talking about properties of matter. I am, by the way, grading all of your tests. Did everybody get your unit tests done in physical science? Awesome. What did you guys think of the format? Are we in the wrong? I have the wrong class here. See what I did, Cody. What did I do? I have all the stuff ready for physical science. That's not till 1:45 this afternoon. What? I know. Wow, for crying out loud. I was getting it all ready for the wrong class. All right. Well, then we're just going to have to kind of, give me 5 seconds here so I can load the other one. I do have that one up ready to go. It's just I don't have it loaded on the screen. Thank you for that. This is not the first time this has happened in my life. But the last time, I believe nobody told me until the class was all over. After that time, I taught the entire wrong class. So, let's try this again. So we are in class number 3. It's all right. I'm all ready for later on. I know. What? It's Monday. What can I say? But I am all ready for this afternoon then, apparently. All set to go. All right. Let's get this one up and running. It is Monday, but I don't know how that happened. All right. Yeah, I was talking about biology. That's what you guys are talking about. Nobody said anything about physical science. I was just tricking you. I was testing you. Yeah, that's a ticket. Just trying to see if you're paying attention. Oh, what can I say? I even slept really well last night. It was my first good night's sleep in a long time. I've been having some rough nights sleeping. I just haven't been falling asleep very well. But today last night I slept like a champ. All right, so ecology is what we are studying. Let's see if I can make sure this is in the right screen here. All right, there we go. We are studying ecology. So this is organisms in their environment. That's what we're looking at. And actually, this is kind of one of my favorite things to talk about in lots of different avenues because this is what we like to do for fun. I mean, if I go out on, we went to Buckhorn State Park this weekend. And much of what we're doing is we're walking trails and we're looking at plants and animals and stuff like that. And my boyfriend's a biologist as well, and he loves to classify different plants. So we're just a couple of biology nerds out there looking at plants, and I love the rocks. Right, it's so fun. I like to look at the different kind of rocks, and he likes to look at the different kind of plants, and I'm learning all about different Wisconsin plants. We saw just one this weekend, actually. They've been kind of hiding a little bit. But it was pretty rainy, too, so they may have just been hunkered down somewhere. The weather wasn't great. But also trying to figure out, butterflies. That's kind of I think I've told you guys I really like to raise the monarchs, but there's all sorts of different butterflies out there. So all of this relates to ecology, the study of organisms and their environment. And that's what we're looking at today. All right. Now, one of the things just as a beginning point here deals with weather and climate, and that they're not the same thing. The climate in Wisconsin is very different from the day-to-day weather. I'm sorry, Devin, that's sad. They're such beautiful, beautiful animals. So our climate here in the fall, right, we could say that we have a seasonal climate in Wisconsin. It varies from season to season. And you can kind of get a general idea of what the climate is like in Wisconsin in the fall. But on any given day, we may have very different weather. So even though the climate is typically a certain way, you might have all of a sudden a week where it's in the 80s and you're in October and it's kind of unseasonal and not normal, not what you would normally expect. So weather changes. Weather's from day to day. Climate is overall. We look at climate. We look at something called, do I have them on here? Nope. Hang on. We look at these things called climatograms when we look at climate. And we're not going to get into them quite yet in a lot of detail. But a climatogram is a chart that shows temperature and precipitation. It is those two factors that really make up climate. Temperature and precipitation. And different regions have different climatograms. So for this particular place, Washington, D.C., we can see the climatogram here is seasonal again, right? So you have temperature in the line graph. So temperature is colder in the winter months. It's seasonably warmer and gets colder again. But rainfall, which is the bar graph here, remains pretty consistent throughout the year. It's a little bit different, right? You may have areas that have really, really distinct differences in rainfall. So, for example, here we have another place. This is in San Diego, California, where you actually see the temperature. It fluctuates seasonally too, although not as much. It gets a little bit, warmer in the summer and cooler in the winter, but the temperature means are very small fluctuations. You're going from about 50 degrees Fahrenheit to about 70, so about a 20-degree fluctuation. In DC, you went, now this is in Celsius degrees, so these aren't the best comparison here, but you're talking about a much wider fluctuation in temperature. In San Diego, the rainfall is much more seasonal. Thank you, Devin. I really appreciate you bringing that up. We are actually having some problems. Blackboard today was not allowing us to record. So the record button is frozen right now. I can't use it. I know. I'm currently recording this, but I'm using the same program that I use to record my video tutorials for labs. It's actually through YouTube. It's Screencast-O-Matic. I'm hoping it works to allow me to record it. Yeah. So hopefully this will record. It might not be as, I don't know, it'll be interesting to see how nice it looks, because it tends to not stay with the Blackboard screen. So if I go on a different screen to get something, it's following me and it's not following Blackboard. So there might be some other stuff going on with it. I don't know. We'll see. But I do appreciate you bringing that up, because I told you guys to make sure you watch for that. All right. So here we have, it's very rainy in January, February, March, and then it's really, really dry. And then they've got their kind of another rainy season again. So again, these are just from year to year, we should expect to see these be the same. And that's what makes it climate versus weather. The things that influence climate are primarily where you're located on the Earth and altitude. Those things. So how far above sea level are you, and how far above and below the equator are you? You should get the warmest temperatures most consistently, so almost like no seasons at all, when you're at the equator. And when you're close to the equator, within 30 degrees north and south, you pretty much have fairly warm temperatures all year round. San Diego falls right there, so it's right in that range. When you're in the mid-latitudes like we are up here, you tend to have more seasonal temperature changes. Same thing down here, right? So the further you are away from that equator, the more seasonal changes you're going to get. You're also going to obviously have changes in your climate based on other things too. For example, if you're in the mountains, your climate's going to be very different than it is if you are, at sea level. And if you're near the ocean, that's going to have an effect on climate too. the ocean acts as kind of a regulator. So if you are near the ocean, even if you are kind of way up here, your temperatures might be fairly mild because that ocean has lots of heat in it. And during the wintertime, it doesn't get quite as cold as it does if you're inland. So when we look at our organisms and things that live inside the organisms, we have some terms, some vocabulary that's used to define all of these different levels of organization, we call them, okay? So we have our levels of organization. We have the largest level is the entire biome. The whole biosphere right here. So the entire Earth, the living part of the Earth, is called the biome, right? Or biosphere. My goodness, I keep saying the wrong word. Biosphere. So every different biome in the world is part of this biosphere. Then we have the biome. And a biome, right here, is an entire area that has the same climate, okay? And you can have various biomes in different parts of the world that all have the same classification. Like you could have, for example, a desert biome in the southwestern part of the United States and in northern Africa. They have the same biome. They're both have the same kind of climate, even though they're not in the same geographical area. And then we kind of look at within the same geographical area, right? We have an entire ecosystem. And the ecosystem is made up of all things living and non-living in a certain area that all live together. And within the ecosystem, we have a community. And the community is just the living part of the ecosystem. So ecosystem is made up of plants, animals, sunlight, temperature, the pH of the soil, the rocks, the water, everything that's found in that area. The community is just the living animals and plants and every other thing, right? So they interact with each other, so plants and animals and obviously predator and prey, and they all kind of have their own interactions, and they all live in the same area. And then we have a population. And a population, bad writing. Okay, we're going to forget that letter. The population is just one type of that community. So here we have a population of, would you say those are elk from that picture? Would be my guess that those are elk in that picture. So we're just talking about our population of elk here. Okay? And then finally, we have our individual within the population. Individual, just one of the elk that we're focusing on, this maybe alpha male within this population. Okay, so that's our levels of organization from largest down to small. So again, biosphere, ecosystem, community, population, and individual. These are our various levels of organization. Remember, we have both living and non-living factors. We use the terms biotic for living factors, and non-living are called abiotic, and they all influence each other. Obviously, the living organisms inside of a river, the fish, the frogs, the algae, the insect larvae, all the things that live inside that river are affected by non-living factors, by how cold or warm the water is, by how much water or light can penetrate that water, so how turbulent that water is, by the flow rate of the river. All of those things have an impact on the living organisms within the river. So they influence each other very, 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 very closely and are very closely related. So looking at this picture, here we have an idyllic ecosystem. Looks like something right out of a Disney movie. Obviously, this is not really doing a great job of illustrating some of those kind of relationships that may not be quite so pretty. Can you guys name some, let's start with just the easy one, do biotic factors. So in the chat box, can you guys put some biotic factors in this ecosystem? Yeah, the turtle down here, beautiful. Maybe a little box turtle, a deer, so pretty. Frogs, raccoon over here. We're naming all the animals. Don't forget about the other parts of the biotic system, ones you can't necessarily. Got our eagle, reeds, some cattails, and other kind of marsh grass and stuff that's growing, trees in the background. The lilies, lily pads, all the plants. Donovan's being very general here, so yes, encompassing all the plants. Can you think of any biotic things that may be going on inside the water you can't really see here? Some fish, sure. Bacteria, nice. Leeches, yeah, lots of different things in there, right? Lots of, gosh, there's lots of like larvae for insects. A lot of insects will lay eggs in the water and they'll have larval forms that form and swim in the water before they take flight later. So there's so many different factors here that are living. Okay, what about those non-living? The abiotic factors. These are a little bit more tricky. The amount of sunlight, very good. The rocks. I'm just going to write these down here. So rocks, sunlight. What else we got here? You can't necessarily see all of the abiotic factors. I'm going to put air quality. There's things about the air. So one of the things would be the quality of the air. What else about the air? Temperature. That could be temperature of the air and the water, right? What else? What other factors of what gases are found? Sure. What about in the water? What tests can we do to the water to check for its quality? How do we test water quality? Does anybody know? The pH? Any other water tests you can think of? One that's really, really important to life is looking at, and somebody said gases here, looking at dissolved gases. Especially, I can't write here, dissolved oxygen. How much oxygen is in that water? Because water that's healthy and can really, really support a very thriving ecosystem would have a very good amount of dissolved oxygen. Water that has poor quality tends to have very low dissolved oxygen, and then you can't get a lot of fish and stuff to survive in that water. It tends to be, we have fancier words for those like eutrophic. So eutrophic water bodies have low amounts of oxygen in them. You can also look at particulate matter. Gosh, let's get really, really technical. How dirty is the water? Is it clear? Does it have a lot of stuff kind of floating in it? You can also look at things like nitrates and phosphates in the water quality. That's going to have an effect on dissolved oxygen. So we'll look at all of these things kind of coming up here. These are all things that can affect the health of the water. Here we have another ecosystem. And again, biotic or abiotic factors, some things we didn't think about before. Look at this. That's part of the ecosystem. Didn't really consider what's going on below the ground before, did we? So what about the soil? Or what is happening underground? Can you think of some abiotic factors down there? Well, that would be a good biotic factor. Yes, Elizabeth, and that's a great thing to think about because sometimes we don't like bugs, we call them, right? But insects are super important to the health of your soil as well as other organisms like worms, like annelids. The rocks that are found in there. Why do you think there's different colors? What do you think that's indicating to us? May know anything about soil? Why would there be different colors? Sand and clay, you bet. Different minerals and nutrients that are found in the soil. The top layer tends to be very nutrient rich, have a lot of organic matter in it. Beautiful, Donovan. I love it. The drainage, how well that soil drains. That is so important. That water is able to infiltrate and penetrate through the soil and percolate down to the groundwater. If it doesn't, you get a lot of runoff. If you get a lot of runoff, you tend to get a lot of poor water quality. And that's going to have a huge impact on that lake or pond back there, even though it looks like I'm circling the nice little red fox. I'm not. Oh, awesome, awesome. Yes, so all those things are important. We can even look at the roots of the soil. There's certain bacteria that live and fungi that live with the plant roots and actually help to convert nitrogen from the atmosphere into usable nitrogen for the plants to take up. We're going to talk about those coming up here in a little bit too. Do we talk about that today? No, we don't talk about that till Thursday, but we will be talking about those biogeochemical cycles coming up this week. All right, so an important term in ecology is sometimes you can pronounce it niche or niche is another pronunciation. I think the book says niche. I've always called it a niche. I think it depends, tomato, tomato on this one. But a niche, a biological niche, is basically, I don't know, the word niche, when you think about it non-biologically, it's like a little spot for something. Like, oh, I'm gonna put this little bench right here in the niche, right in the corner of the room, because it's just a little spot, just perfect, just for this bench. It fits it perfectly. And that's kind of what it is biologically. It perfectly fits a specific organism. And it's not just the physical location, but that is included within the niche. But it is also all of the factors that organism relies upon. The amount of sunlight, the available nutrients, moisture in the soil, depending on which organism we're talking about. The thing is that only one organism can occupy any specific niche in an ecosystem at one time. So if that niche is filled, then it can't be occupied by two different organisms. If there is a kind of a struggle for that, that's competition, right? So we have what's called the competitive exclusion principle. It's a very important principle in ecology, that no two species can occupy the same niche at the same time in the same habitat. That they're going to compete with each other. It's a winner-take-all situation. If one organism is outcompeted, that organism has to find a new niche or is just, eliminated from that ecosystem. Okay? Think about, for example, you have two trees in a forest, and they're both competing for the same physical space. They're both competing for the same sunlight that's available, and they're both competing for the same nutrients in the soil, the water, etc., etc. At some point, one of those two trees is going to survive while the other one dies. That's the competitive exclusion principle, okay? Winner takes all. Competition's a real reality in nature, right? Predation. One organism captures and feeds another. You have the eater and the eaten. We see this all the time. I'm sure many of you guys have seen some of those nature shows, where you watch animals like in the African safari, the lion devouring the zebra, maybe something like that. Even if you've seen The Lion King, for crying out loud, predation. Oh, absolutely. Now, not a natural necessarily, because cats aren't naturally part of our ecosystem here in the U.S., although I have a cat of my own who brought me a dead mouse yesterday. But then again, we also have, probably more mice than we need because they also are lacking some of their natural predators, right? So, yeah, give me an example in an ecosystem. Try to keep it local if you can, if you'd like to. I'd love to be able to think of examples in Wisconsin of animals or other organisms. You can think of plants, where you can think of a example of predation. What do you guys think? ants in your garden. What are the ants eating? I have a great example. Your plants, sure. The eater and the eaten. Oh, I hope not. Do you have some bear attacks in your area? In general, people are not a natural food source for bears. But what would be a natural food source for bears? Because what would be a good natural food source for bears? Yeah, they tend to eat plants. How about other animals? What animals do they typically feed on? Sometimes, yeah. Coons and frogs, okay. I don't know. Do they attack and eat a lot of deer? I would think that'd be harder, but maybe it happens. They do fish a lot too, don't they? Don't bears eat a lot of fish? My understanding is at least black bears are typically more foragers than hunters. I mean, they're hunting, yes, they're getting hunters and foragers, but they do typically get fish and small game. I don't know if they do attack deer? Trout, okay. I was thinking of, going back to my old monarch example, ants. The ants actually do prey upon the monarch butterfly caterpillars on milkweed, so they tend to prey on them. It's a definite predator-prey relationship. It is what it is. It's natural, right? The idea with the monarch preservation is that we're now taking a situation that this is a natural relationship, but we as humans have made it. We've made them so that their habitat is being encroached upon. That that they are more scarce because of our activity, and that's why we try to help some of these creatures. Not because, in general, you should just leave them alone. But if human activity has somehow reduced their numbers, then I think it's our responsibility to come back and say, hey, we screwed up. Let's fix this. And that's what we're trying to do with the monarchs. So we have predation. We have symbiotic relationships. Now, symbiosis is oftentimes looked at as a positive thing, but there are actually 3 different symbiotic relationships, one of which is not positive at all. Basically, symbiosis just means you live in a very close relationship with something. You're affecting it and it's affecting you. You're relying upon each other. It might be a positive way, and it might not be. The positive, or most positive, is mutualism. A mutualistic relationship is one where there's an equal benefit. You're helping it, it's helping you, right? The bee pollinates the flower, so it helps with the reproduction of the plant, in this case a purple coneflower, beautiful native species to Wisconsin. And the flower is providing food for the bumblebee here, right? A commensalism is a relationship where you have one organism that's benefiting and the other one is just kind of like not being helped or harmed or anything. It's really just almost oblivious to that relationship. Now, I've been told that this is actually mutualistic, right? So the sea anemone gets cleaned by the clownfish has a place to hide. That's a mutualistic relationship. What about a commensalist relationship? Can you think of an example where one organism benefits, but the other one is neither helped nor harmed in the process? It's kind of just doing its thing. Doesn't really know what's going on. A little harder to think about. I think probably the most common one that I can think of is a bird nesting in a tree. Okay, so the bird uses the tree for camouflage, for a place to live. The tree doesn't really benefit from the bird being there, but it's not harmed by the bird being there, right? So that's a good example of commensalism. And then our last one is parasitism. So if you're a parasite, you are harming your host. The host is getting harmed. The parasite's benefiting, but the host is being harmed. This is just an awful example of a picture of, I think it might be a, oh my gosh, it's some sort of fly. I can't remember the name of the fly now, that lays its eggs inside of you. It stings you, or it lays its eggs, and then the larva actually, maybe a botfly? Yeah, I think it's a botfly. And then the larva escapes through like this horrible, you have this horrible like festering wound, and then the larva just pops out of it. It's really nasty. It's a botfly infection. I thought that's what it was called, Donovan, but it was like, I was saying it, that somehow doesn't sound right in my head, even though that's what I thought it was. All right, we're actually not going to talk about succession yet. We're going to get into that a little bit coming up. Well, I'll talk about it briefly, but then I want to get into it a little bit more because I learned a lot about this weekend, which was pretty cool. So ecological succession is where an environment is going to change. Think about your ecosystem. So the ecosystem changes over time, and certain things can kind of force it to almost reset itself in a way. So for example, we have the two main types of succession are primary and then secondary succession. Most succession that occurs is secondary. It's very seldom that you have primary succession. Primary succession occurs only where no soil exists at all. So probably the best example is after a volcanic eruption. So when a volcano erupts, it's just rock. It's just igneous rock. So you don't even have any soil at all. So you first have to get soil forming before you can get plants. And the first organisms that usually populate an area after a volcanic eruption are these things called lichens. Lichens are a great example of a mutualistic relationship. So a lichen is an example of an algae that lives in a mutualistic relationship with a fungus. And you guys have seen lichens many different places. They're all over the place. You probably call them mold or moss, maybe. Sometimes they are green like this. Sometimes they have more of a lime green color like this one. Sometimes they're rusty in color. They can grow on old logs. They can grow on rocks. And that's what goes on after a volcanic eruption. The lichen will actually grow on the side of the rock, and it can break down the rock. The lichen actually will secrete like acids that will break down the rock and extract minerals from that rock, and those minerals can be used kind of as a food source, right, for the fungus. The algae that lives in here does photosynthesis. So you get more food that's being, provided by the algae. So the algae has a place to stay. It can stay within like the structure of the fungus. And the fungus gets food from the algae doing photosynthesis. So they have a great mutualistic relationship. And as a result, they break this rock down and turn it into soil. So eventually soil is formed through the action of this lichen. And when soil is formed, you can finally get some smaller plants and things that can, some seeds that can come take root in that soil, and you can get more plants that will form, and you get the ecosystem starting to change. Secondary succession occurs when there's a forest fire or something, and the whole area is wiped out, but the soil is still intact. So it's almost like taking something if you have primary succession and you fast forwarded it years and years and years and years, so when you finally do have soil, that's kind of where that secondary succession begins. Secondary succession, a lot of times it's just smaller plants and stuff that start to grow in an area first. And one of the things I learned over the weekend is in our area, we have a species of tree called a jack pine. You guys know what a jack pine looks like? Have you ever seen a jack pine? They're native. They're one of 3 native Wisconsin pine trees. We have red pines, white pines, and jack pines in the state of Wisconsin. Jack pines are smaller than red pines and white pines. Typically, they don't grow as big. The needles are a little shorter. And they tend to be one of the first trees to grow in an area of secondary succession. Okay, so in an area where you have a lot of jack pines, and I'm trying to find a good picture, but I'm struggling. I took some with my camera, but I didn't have a chance to, because I literally just learned this like day before yesterday. So jack pines are, one of the, here we go, like a jack pine forest in Wisconsin tends to be a fairly young forest. So a lot of times what will happen is when they go through an area and they cut it down, they cut down a lot of the trees and stuff in there, they do some forestry in that area, the very first trees to come back are jack pines. And it's kind of an open area, looks like this. Smaller pine trees. Over time, you'll get some red pines and white pines that'll come in. And jack pines, I guess, also have a very much shorter lifespan than red pines and white pines. So those jack pines will die back, and the red pines and white pines will fill in the area. And it's changing, right? It goes from it starts as a kind of an more open area. This is actually a beautiful picture of an oak savanna on the bottom here, but that area will change over time, and that's what succession is. Succession is how the ecosystem changes through time, and usually there's some sort of kind of reset button, right? And it can be like a volcanic eruption, which is not something we'll see in Wisconsin, but it can be like a forest fire, or it can even be something that's done by humans. They might log the area and just have to, reset from scratch, new or new plants and stuff start to fill in and kind of reestablish that area. And logging is actually something that's very healthy for the ecosystem. We don't really have a lot of forest fires today because we control a lot of that with our controlled burns and things like that. We don't have nearly as many as they used to have. So the logging kind of helps to restore those natural situations. All right, ladies and gentlemen. It can be, overlogging can be very bad, but selective cutting is actually very good. The difference, if you had the choice of having nothing versus select cutting, you want the select cutting. It's better for the environment. A prime example is this picture at the bottom, which I put this picture in this slideshow a few years ago without knowing what this picture was. This is a beautiful picture of something I learned about called an oak savanna, which are actually a natural part of the ecosystem in the western part of Wisconsin. Oak savannas are great because they provide a lot of grassland and shrubland, but they also have these big oaks in the area. They're also a place where we see there's a specific kind of butterfly that's native to western Wisconsin called the Karner blue butterfly. I don't know if you guys have ever heard of that, if you're from that area. I was just in that area near Necedah and this weekend. The Karner blue relies specifically on a plant called blue lupine. Blue lupine, or wild lupine, wild lupine only grows in the oak savanna. So if this whole area were left to its own devices and it just filled in with forest, it would completely wipe out those natural oak savannas and the Karner blue would become extinct. The Karner blue is actually an endangered species right now because of human activity. We planted lots of trees for the logging industry, right? We actually went through and kind of disrupted a lot of these natural oak savannas. So there's a lot of restoration projects taking place in that part of the state right now. They're restoring oak savannas by cutting down lots and lots of trees. And it looks like, from people who don't know what's going on, like, oh my gosh, they're cutting down so many trees, why are they doing this? But they're actually trying to restore this natural habitat, which is really good for not just the Karner blue butterfly, but a lot of organisms that need to have this environment to survive. All right, I talked too much today, but we hopefully you learned a little bit, and we'll continue on with this next week. I don't know, does anybody know who Isaiah was who just left? Because he left early and didn't have a last name, so I don't know who it was. All right. Well, if you do know, let me know. Otherwise, you guys have a great day. Thank you for not letting me teach you physical science. I'll talk to y'all later.